2.6 presents the Optical Test Instrument family. Firstly, I'll be covering our Waveshaper family of programmable optical processors. With the Waveshaper, you can create custom filters with arbitrary attenuation and phase across the full wavelength range. As well as this, you have full wavelength selective switching capabilities to multiple output ports. These powerful features of the Waveshaper are used broadly in labs and manufacturing facilities across various industries, including telecom, sensors, medical, and laser pulse shaping. Next, I'll cover our Wave Analyzer family of high-resolution optical spectrum analyzers. The Wave Analyzer family combines high-resolution measurements together with fast scan rates. Measurements with a resolution as precise as 180 MHz can be taken with scan rates of up to 10 Hz. I'll introduce you to each of the Wave Analyzer models and provide an overview of the various analysis capabilities available in the user interface. Before I begin, I wanted to share some new developments in the Waveshaper family. In addition to the C-band, the L-band, and the 1 micron window, the Waveshaper family now also covers the S-band and the extended L-band windows of optical communications. This extends our total combined range from 1468 nanometers all the way up to 1640 nanometers. Alright, let's get started. I'll first walk you through our measurement setup for the demonstration. We will be using two different optical sources. The first is a 10G tunable XFP transmitter. It contains fine spectral features not typically resolvable by conventional grating-based OSAs, and we'll see how the high-resolution capability of the Wave Analyzer allows us to resolve and analyze such fine spectral features. Our second optical source is an erbium ASE source, which we'll use to produce a broadband spectrum across the entire C-band. Our optical source is connected to the input of our Waveshaper. The Waveshaper outputs are each connected to our three Wave Analyzer models. Port 1 to the Wave Analyzer 1500S, Port 2 to the Wave Analyzer 200A, and finally Port 3 to the Wave Analyzer 100S. Let's take a look at how the 10G tunable XFP transmitter looks when measured using our Wave Analyzer 1500S. The 1500S is configured with the most precise resolution setting of 180 MHz or about 1.4 picometers. Okay, so let's bring up the Wave Analyzer software here, and you can see we have the XFP transmitter being measured. Let's zoom in so we can take a closer look. As I modify the modulation pattern, you can see the introduction of new spectral features here. You may also notice the center frequency of the modulator also drifts around. And this drift is not an artifact of the measurement system. This is a true drift in the transmitter. We're able to resolve these tight spectral features while also capturing the center frequency drift. This demonstrates both the high resolution and the fast scan capabilities of this instrument. I'm now going to switch to our broadband source, and I'll use the Waveshaper to carve out particular spectral patterns so that I can demonstrate the various analysis functions available in the Wave Analyzer software. Let's first take a look at the multi-channel analysis. The Waveshaper was configured to output a series of 50 GHz channels, and this analysis mode allows us to measure the center frequency, power, and OSNR value for each channel. We have a variety of settings that allow you to specify exactly how your channel plan is defined, as well as configure in more detail how the center frequency, power, and OSNR values are calculated. By default, OSNR is calculated using a 6-point method. These points determine where the OSNR algorithm samples the noise and the signal powers. Zooming into the graph reveals the location of these OSNR points, and we can drag them around to suit our particular requirements. The Wave Analyzer software also features a wavelength meter mode. In this mode, a peak detection algorithm is used to determine the locations of one or more signals. The center frequency and contained power is calculated for each detected signal. Also available for each peak is the 3 dB bandwidth, 20 dB bandwidth, as well as a user-defined bandwidth. And just like the multi-channel analysis, the wavelength meter mode also includes a variety of settings to configure in more detail how the algorithm works. The third analysis mode I like to cover allows you to take side mode suppression ratio measurements, which are of particular importance to laser manufacturers. With the SMSR mode active, you'll see the measured SMSR printed in the pop-up, as well as some other important metrics such as the side mode frequency and power. You can configure the stop band, and the stop band is what differentiates between the signal and the side modes. And so it should be set large enough to contain the laser line, but small enough not to reject any potential side modes. I've now switched from the Wave Analyzer 1500S to the smaller Wave Analyzer 100S, and just like its larger, more precise cousin, the 100S may also be used to perform the same analysis features I've just described. And that about wraps it up for the showcase on the Wave Analyzer analysis functions. Let me now show you our portable optical spectrum analyzer. This is the Wave Analyzer 200A, a completely portable optical spectrum analyzer featuring a touchscreen and an intuitive user interface. Navigating your measurement is quick and easy. You can pan the graph around by dragging a single finger across the screen. And you can also zoom in and out by pinching with 2 fingers. The user interface is full of useful features, including the same multi-channel analysis tool discussed previously. Center frequency, power, and OSNR measurements are shown for each channel. And once again, this mode can be precisely configured to suit your particular use case. If assistance is needed, there is a dedicated help section available on the device itself, covering a wide set of topics, including an overview of all of the functions, as well as details on the Ethernet interface and API for programming for remote applications. Lastly, this device also supports multiple languages, supporting English, Chinese, Japanese, and Italian, with more supported languages coming in the future. And that brings us to the end of this demonstration. In case you would like further information, please check on 26.com/instruments or contact us at Waveshaper@finisar.com.